this is our final section in this unit. Like I said earlier today, that this is a short unit, so we're only doing 3 lessons. We've already done part of this before with the equations, but today we're going to add the inequalities to it, and there is a little bit, even with the equations, that we are going to add that we have not done before. So we're going to go ahead and start with example 1, and this is solving multi-step equations. So the first part of this, when we have the grouping symbols, would be to distribute to whatever's in front of the variable. So for this particular problem, we have to distribute the 3 to both the d and the 2. So 3 times d, remember you multiply it, gives us 3d, plus 3 times 2 gives us 6, is equal to 12. So now remember, when you go backwards of the equation, we add and subtract first. So I'm going to subtract 6. So I end up with 3d is equal to 6. And then I divide by 3, and we get d is equal to 2. So that's that answer. So those are the ones we've done before, so that's nothing new. Over here, it's kind of the same thing, except we're dealing with inequalities now. So again, we distribute. So we end up with 4x minus 12 is greater than 6. We add 12 to both sides. So we get 4x is greater than 18. We divide by 4, so we get x is, not equal to, x is greater than 4.5 or 4.5. And we're not going to worry about graphing these just yet, because that's the same that we had done before with the open and closed circles. Alright, so the next example, sometimes we're going to see this, is that sometimes you might have grouping symbols on both sides of the equation. So we can do that all in one step. So as we look at this next example, that's something we can do all in one step. So I don't know that we did this before, but if I have something like 4 times x plus 5 is equal to 3 times 2x plus 4. So again, we distribute on this side, the 4 to the x and the 4 to the 5. So we end up with 4x plus 20 is equal to, and then I can do the same thing over here, 3 times 2x and 3 times 4. So that gives us 6x plus 12. Now again, we do the same thing here that we did in the couple of sections ago, where you determine which side has the higher coefficient. Here's the higher coefficient, so I'm going to move the 4x by subtracting it. So that we get 20 is equal to 2x plus 12. And we subtract the 12. So 8 is equal to 2x. Divide by 2, which means that x is equal to 4. So same idea, there's just more steps in the beginning because you have to distribute on both sides of the equation. Now the same thing can be done with inequalities, and that might happen occasionally as well. So for example, 3 we're going to look at a multi-step inequality. So on one side we have 5a minus 8 is greater than or equal to 4 times a minus 3. So again, we distribute here, so we end up with 5a minus 8 is greater than or equal to 4a minus 12. We want to know which side is the higher coefficient. It's this one, so I want to move this side. So we end up with a minus 8 is greater than or equal to negative 12. I add 8 to both sides, so then we see that a is greater than or equal to a negative 4. So remember, if they're opposite signs, subtract and keep the sign of the higher number. And again, if we wanted to graph that, same as we did before, we have the negative 4. It's greater than or equal to negative 4, so it's a closed dot. And it goes this direction. So now, the next thing we're going to get into here is really what's the new part of this whole section. So this is all a little bit of review from a couple of units ago when we did solving equations, but some of that's new. However, here's the big new piece. Sometimes we're going to have an answer that is not true or that's always true. So we're also going to have, sometimes we're going to have no solution, and sometimes we're going to have all solutions. A no solution means that we have the empty, or what we call the null set. And what the empty set, this just means that there is no solution that exists that will satisfy the equation that we have. It means the two sides cannot be equal. So the symbol that we use for that is a 0 with a slash through it. So if you see that, that means there is no solution for the equation that we're going to have. And I'll show you an example here in a minute. All solutions means that any number you put in there is going to satisfy both sides of the equation. There isn't just one thing. So that we say that's all real numbers. And we use the symbol, it's an R with a double line down it. So let's take a look at how do we identify each of these situations and what does that look like. So this will be example number 4. The first part says to solve the equation 3 times y minus 5 plus 25 is equal to 3y plus 10. So we start by distributing, so we end up with 3y minus 15 plus 25 is equal to 3y plus 10. Combine like terms, 3y, negative 15 plus 25 is a positive 10, is equal to 3y plus 10. And notice that we have the exact same thing on both sides. So whatever I would put in for y is going to give me the same number on both sides of the equation. So it doesn't matter what I would put, so that we can say that this is going to be all real numbers. Because it doesn't matter what we put in there, both equations are always going to be equal. So sometimes that's going to be the case. And so anytime you see that both sides of the equation are the exact same thing, and sometimes you might have it where you just get a number is equal to a number. So if I subtracted 3y from both sides, we would get that 10 is equal to 10, which implies that it's all real numbers. So it doesn't matter kind of how you look at that. If you get rid of the variable and you have the same number on both sides, the solution is then all real numbers. Now, to get the identity, or the empty set, let's look at this equation. We have negative 5x minus 14 is equal to 2 times 2x plus 3 minus 9x. So if we look at this equation, again, we start by distributing. So this side stays the same. This side becomes 4x plus 6 minus 9x. Combine like terms on the same side first before we move things around. And because we have the same coefficient on both sides, it doesn't matter which side we move it to. So I'm just going to go ahead and add 5x to both sides. Notice though that cancels it on both sides, and I'm left with a negative 14 is equal to 6. Well, negative 14 is never equal to 6. That can't happen. So we say there is no solution. Nothing is going to satisfy this. This side of the equation will never be equal to that side of the equation. So this is really the big new piece, and this is what I want to spend the next couple of days on, is really practicing and identifying when do we have all real solutions and all real numbers, and when do we have no solutions, or the empty set, the null set. So that is the lesson. So we will do some practice on this for the next couple of days before taking a test on the end of this unit.